Hi, we have the AP Physics 1 past paper 2016. We are discussing the section free response question. We have question number 3 for the 12 points. According to the question, a long track inclined at angle theta according to the fig to the horizontal has the small speed bumps to it. The bumps are evenly spaced at the distance d apart as shown in the fig above. The track is actually much longer than the shown over the 100 bumps. Okay. The cart of mass m is released from rest at the top of the track. The student noticed after reaching 40th bump, the cart average speed between the successive bumps no longer increase. Reaching the maximum value of V average, this mean time interval to move from one bump to next bump become constant. Okay, that's the observation he has. Now, according to the first part of the question, consider the cart motion between the 41 and 44 figure below. Sketch the graph of the cart velocity as a function of time from the moment it reaches the bump 41 until the moment it reaches the bump 44. This is a given fig, we have to draw that. The cart has reached the steady speed 40th bump. Okay, the meaning average speed between the successive bump become constant according to the given observation of the student. Time interval between the bump is constant. This implies velocity pattern repeat periodically because the average speed is constant, time is constant. When cart moving with the bump, only force driving down it's the component of the gravity, that is mg sine theta. This create constant acceleration. A is equal to g sine of theta. Okay. Then velocity time graph, positive constant acceleration mean we are discussing this one. This is the positive up increase in velocity with the time. So positive constant acceleration represent the straight diagonal line sloping. We have to come straight diagonal line sloping upward. We have the highlighted this one. When the bump, a cart hit the bump, lose energy, slow down very quickly. So this is the part which represent it comes to it lose the energy. So sharp vertical drop in a velocity. So that's the representation of the curve. Over the same intervals, that rather dashed horizontal line V average, label the line V average. So in this case, we can see that's the average line we have highlighted there. So in steady periodic state, average speed successive bumps are the same. Cart create maximum average speed when the energy gained by the gravity between the bump is equal to the energy lost by the bump. So that's the physical meaning in term of energy. Now next part, distance between the bumps is increased, but everything as same. Is maximum speed of the cart now greater, less or same with the bump closer together? Explain your briefing. Okay. Now maximum speed of the cart is now greater with the when the bumps closer together according to the question when distance between the bump are increases. Now why it is speed increases? Explanation, cart accelerate constantly under the action of gravity is equal to g sine theta. Now if the distance is increased, cart has more time, more distance to accelerate before it gets stopped by next bump. Since it accelerates longer, it will reach higher speed. According to this equation, when the d is increasing on the right hand side, left hand side, initial velocity is constant, the final velocity has to increase. From point of energy, work done by the gravity is Fd. When d is increased, gravity does more work caught between the bump, given it more kinetic energy. More kinetic energy mean higher speed. So in every aspect we have discussed from the acceleration point of view, mathematically and energy point of view. So its maximum speed now in this case would be greater. Okay. When the bumps return to the original spacing, track is tilted greater angle theta. Is the maximum speed of greater, less or same? Reasoning. Now maximum speed of the cart is greater if the ramp angle was smaller. Mean when the angle is greater, now the speed is greater. The force pulling the cart is gravity, specifically the component mg sine of theta, sine 0, 0, sine 90 is equal to 1. When angle is greater, the value of mg sine theta is greater, mean force is greater. Larger theta, value of sine theta increases, meaning acceleration increases. Higher acceleration means for the same distance, cart will reach significantly for higher speed. So g sine theta increase. So Vf on the right hand side, so have to Vf should be increased. Now, before arriving at an equation such as V average, it can be useful to come up with an equation initiative expected to be true. That's why derivation can be checked later. It can be make sense physically. A student come up with the following equation for the cart maximum average speed. C mg sin theta by d, where c is a positive constant. To test the equation, student rolled the car down for the long track with the speed bumps many times in front of the motion detector. The student varies the mass of the cart each trial but keep everything same. The graph shows below the student plot data V average as a function of M. Are the data consistent with the student equation? Yes or no? Brief your explanation. From the given equation, V average is directly proportional to the mass. Mathematically, directly proportional must be the straight line that passes through the origin, but this curve doesn't pass through the origin. It is, it is expected to be point cut at the point 8, point 9, not the 0. For graphically, for directly proportional, the line should be like that. So, because the data implies non-zero y-intercept, it is not consistent with the student hypothesis, proportionality of student equation. Again, looking at the graph, doubling the mass doesn't double the velocity. Mean when the mass from 1 to 2, it should be 4. It should be like that. This one. When mass is 1, velocity is nearly 1.25. When mass is 2, is nearly 2.1. It should be 2.5, mean almost double. So equation indicate it should be double. Therefore, plotted data is inconsistent with the student formula. Okay. Gravity gives the something have to remember. Gravity gives some same acceleration to all masses. So speed reaches between the bump don't depend upon the mass. Okay. Another student suggests that whether the not the data above consistent with the equation could be incorrect for other reason. Does equation make physical sense? From the equation V average CMG sin theta by D, V average is inversely proportional to the D. According to the equation, a longer distance corresponds to smaller average because the inversely proportional. But according to the part B of the question, bigger distance between the bumps leads the larger average speed, showing the equation is implausible. So that's the answer. If you have any query, kindly ask in the comments. Okay, take care.